Lesson 5-2, Solving Inequalities by Multiplication and Division. Essential question. What causes the symbol to flip when multiplying an inequality? So this is the same rule that you needed to remember from 5-2 day 1. It's that if you multiply or divide by a negative number, you must flip your inequality symbol around. And I'm going to show you why this is true. In 5-2 day 1, I showed you why if you multiply or divide by a negative, you have to flip it. This time I'm going to show you if you multiply, why you have to flip it. So let's write two inequalities. Let's say 5 is greater than 2. 5 is greater than 2. So first I'm going to multiply both sides by a positive 2. And then I'm going to multiply both sides by a negative 2, and we're going to see what happens. 2 times 5 is 10. 2 times 2 is 4. Is 10 greater than 4? Yes, it is. So that is correct. 2 times negative 5 is negative 10. 2 times negative 2 is negative 4. Is 10 greater than negative 4? No, it is not. You have to flip your inequality symbol in order for this inequality to stay true. So that's why the rule says you must flip your inequality if you multiply or divide by a negative. When we multiplied both sides by a negative 2, our inequality became untrue when we solved. So we have to flip it around in order for it to remain true. Solve and graph. So we have x divided by 2 is less than or equal to 11. I'm going to draw my train tracks. The opposite of x divided by 2 would be timesing by 2. So I'm going to times both sides by 2. My 2's cancel. Bring down the x. Bring down the inequality. I times by a positive 2, so I don't have to flip it. 11 times 2 is 22. Now I need to graph it. A quick way of graphing is I always put the number that I ended up with, so the 22 in the middle. Then I put one number smaller on the left, one number bigger on the right. Since this one was less than or equal to, I need a closed circle. My variable's on the left, which is perfect, so I can turn my inequality into an arrow. My arrow is pointing to the left, so that means I need to shade to the left. Let's see if that makes sense. If x is less than or equal to 22, numbers that are less than or equal to 22 would be 22, 21, 20, and so on. Are those numbers shaded? Yep, 21, 20, 19, all those numbers ended up shaded. So that is my answer. Negative 8 is less than or equal to negative x over 5. Now that negative sign, I would assign that to the 5. Really, it means that that whole fraction is negative. So I think the easiest thing is attaching it not with the x, but with the 5, and timesing both sides by a negative 5. My 5's cancel, bring down the x. Since I multiplied by a negative, I have to flip my sign. Negative 8 times a negative 5 is a positive 40. Now before I graph this, I always want my variable on the left. So I'm going to rewrite it with the x on the left, the 40 on the right. My Pac-Man mouth is eating the 40, so my Pac-Man mouth needs to eat the 40. Now we're ready to graph. I'll draw my number line with a 40 in the middle, a 39 on the left, and a 41 on the right. This time I need a closed circle again because it's less than or equal to, and then my arrow is pointing to the left. Numbers that are less than or equal to 40 are 40, 39, 38, 37, 36, and so on. 1/2 x is less than negative 6. Train tracks. Now think back to chapter 2. What did we do when we had a fraction? The way we get rid of a fraction is by timesing by the reciprocal. So the reciprocal of 1/2 is 2 over 1 or 2. You can write it as a fraction if you want, but if it makes a whole number, I usually just multiply by the whole number. 2 over 1 times 1 over 2 makes 1. I have to ask myself, did I times by a -2 or a +2? I times by a positive, so I don't have to flip the inequality. -6 times 2 is -12. My variable is on the left, so it's ready to go. I can graph. Now remember, if I have a -12, the number on the left is -13, the number on the right is -11. Think about how a number line goes. This time I have an open circle. My arrow is pointing to the left, so I'm going to shade to the left. X is less than -12. Numbers that are smaller than -12 are -13, -14, -15, and on. -2/3. X is less than -6. So I have a fraction, which means I have to times by the reciprocal. It doesn't matter which number has the negative in front of it. This negative just means the entire fraction is negative. It's not just the 2 that's negative, it's the whole thing. So I'm going to times again by -3 over 2. It doesn't matter which number has the negative in front of it. These would make 1, so I'm going to X them out. I times by a -3 over 2, so I have to flip. Now, if I want to multiply a whole number by a fraction, I can turn that into -6 over 1 and multiply across. -6 times -3 is +18. 1 times 2 is 2. 18 over 2 is 9. The variable's on the left, so that means that it is ready to graph. Put a 9 in the middle, an 8 on the left, a 10 on the right. We need an open circle on 9. My arrow is pointing to the right. X is greater than 9. Numbers that are greater than 9, 10, 11, 12, 13, 14, 15. Now we've got a couple word problems. We're still going to use the same SUI that we used in lesson 5.1 to help us write our inequalities. Remember, SUI is start with, operation, unknown, inequality, and ends with. Jessie has more than 45 CDs. This is about a fourth of the amount that Sue has. How many does Sue have? We always start with our unknown, which is easy. We'll just put a variable in there, x. Our inequality is more than. More than is greater than. Our ends with is our biggest amount. What's our biggest amount? That is the 45 CDs. So now we're just left with the starts with and the operation. Starts with is always the other number they give us, so that's 1/4. And I want you to look carefully at that problem. Where do you see an operation in that problem? The operation comes right after the 1/4, and that's the word of. The operation for of is multiplication. So that means I have 1/4 times x is greater than 45. So if I want to solve that, I have a fraction 1/4, so I have to times by the reciprocal, 4/1, or 4. That makes 1. If I do 45 times 4, I get 180. So that means Sue has more than 180 CDs. One more word problem. Luke needs at least $3,500 to buy a car. If he earns $8.50 per hour working, how many hours will he need to work to buy the car? Let's start with our unknown, which is x. Our inequality this time is at least. At least means greater than or equal to. Ends with, our biggest number in the problem is 3,500. We're starting with the other number, which is 850. And our operation this time, it's 850 per hour. Per means to multiply. So if I have 850 times x is greater than or equal to 3,500. So then if I solve that, I'd have to divide both sides by 850. And I'd end up with 411.8. So here's what that means. That means that Luke needs to work more than or equal to 411.8 hours. 411.8 hours. Now if you think about how, in general, people work about 8 hours a day. So if I take 411 and divide it by 8, that means Luke has to work for 51 days straight in order to pay for the car, or maybe roughly 2 months if he has a couple days off here and there. Summary. The homework for this lesson is page 293, numbers 2 through 5, 10 through 20, 30, and 33.